Welcome to video number 10, and today we're going to talk about eccentricity of an ellipse. So if I said to you that someone was a little eccentric, what does that word mean? Well, we know it to mean someone or something that's a little different, a little out of the ordinary, doesn't always fit the mold perfectly. So to say that ellipses have eccentricity means that they're a little weird looking, right? They're not perfectly shaped like a circle would be. So the formal calculation or formula to calculate eccentricity, which we're going to denote by the letter E, is we're going to take the letter C divided by A. Okay, now let's review what these meant. Letter C was the distance from the center of the ellipse to the focus point. Okay, and remember that the letter C was always on the major axis, and A was our major radius. Okay, so to calculate eccentricity, I take C divided by A. Now, eccentricity is allowed to be less than 1, since it's a fraction, but it can be greater than or equal to 0. And in a minute, I'm going to do a really good demonstration on GeoGebra just to show you exactly what it looks like. But if something has 0 eccentricity, this would just be a circle. Okay, and we're going to see in a minute that eccentricity cannot be equal to 1. If C were equal to A, we'd actually have a straight line and we would no longer have an ellipse. So the important thing to note is that eccentricity must be slightly less than 1. So I'll show you the demonstration in a minute, but let me kind of give you just a little guideline of what it'll look like. So a circle is going to have absolutely no eccentricity. As I start to get more and more oval shaped and oblong, the eccentricity number actually increases. So let's say I have something like this. This is a little more eccentric than our circle. So the eccentricity number is going to be a little higher, and I'm just going to make up a number. Let's say this is 0.4. Well, let's see if I can make it even more eccentric, right? What if I stretch it out, make it look even more oblong, right? So maybe this is, 0.8. And again, I'm just sort of making this up. And then finally, I could do something really crazy. I can make it look really, really weird, right? Make it super thin ellipse like that. This would have an eccentricity of maybe 0.95. And as I got more and more eccentric, the ellipse would get more and more sort of oval shaped, and it would almost start to look like a straight line. Once it got to be 1, I'd no longer have an ellipse because I would have a straight line. Okay, so remember that on GeoGebra, we have a pre-calculus book, and you can Google it and search it free anytime. And there's a really good demonstration of ellipse eccentricity. So right now, I'm just gonna sort of toggle off of the tripod here, and I'm gonna show you my computer, and I have it pulled up. So if you go under GeoGebra, ellipse eccentricity, you can click on that. You can play around with this really cool demonstration. So here you can see that I have a circle, and you can see that it's graphed perfectly. And circles are perfect, right? They have no eccentricity whatsoever. So the eccentricity calculation is 0, all right? You can see that it's 0. I didn't even really talk about eccentricity when I talked about circles because it doesn't really exist. Okay, now as I move E, okay, so I make the eccentricity a little bit higher, you can see that I start to become more and more oblong. And notice, look at the focal points, right? The C distance is from the origin or the center of the ellipse here. This is the distance C, and this whole distance here is A. Remember, A goes all the way to the vertex. So watch what happens. I keep going. I'm getting more and more eccentric, right? The higher the number, the more oblong the ellipse is. And you can see Now this isn't very good. See, if I go to 1, right, you could see that I no longer have an ellipse. This would be a straight line. This is why the eccentricity can't equal 1. So just a cool demonstration of exactly how weird the ellipses are, how eccentric they are. The higher the eccentricity number, sort of the more oblong they look. So I would go on GeoGebra. I would search the pre-calculus accelerated honors book, and it's called Ellipse eccentricity, and you can just search it, Google Mrs. Bailey's pre-calculus accelerated honors, and this will come up, and you can play around with it and just sort of explore. Okay? All right, I will see you in the next video.